Right now, I want you guys plotting these 3 points. This is a dilation. You've done dilations before last year. Only thing new is you're not dilating from the origin. I need your attention up front. All right, so plot A, B, and C. So A, you go left 10 and down 8. Left 10 and down 8, and label that A. Keep going and do all of them. You will be connecting them to make a triangle, yes. All right, because this is a horizontal line and this is a vertical line, is this a right triangle? Yes. All right. Let's go ahead and work on the dilation. What I'd like you to do right now is first note that you're using this as the center of dilation, -12, -10. So plot that point now. Go left 12, down 10. All right, so this, for me, this red dot is going to be my point of dilation. What is the scale factor? Read up here, the scale factor is what?
2.
2. With the scale factor being 2, does that mean it's going to get bigger or smaller? Bigger. How much bigger?
2 times bigger.
2 times bigger. Good. All right, so what you do is this. I'm going to start with A. Right now, I want you to count your rise over run from the point of dilation to point A, to your vertex A. Up and over. Count it right now.
Up 2, right 2.
Does everyone agree with him? All right. What you do when you dilate is you repeat that any number of times depending on what your scale factor is. I need you guys listening up front. All right. So we're going to go up 2 over 2 twice. Up 2 over 2, that's one time. Up 2 over 2, that's the second time, and that's called A prime. If it had been a scale factor of 3, I would have done that one more time to make a third time. Make sense? All right. Now we're going to do the same thing. I want you to count your up and over from the red dot to vertex B. Okay, so count up and over right now from the red dot to vertex B. Okay, does everyone agree? Okay, so I go back to my red dot and I go up 8 over 2. 1, 2, 3, 4, 5, 6, 7, 8 over 2. The first time I do it, should I end up right on the dot? The dot that I'm counting to?
Yeah.
Yeah, and then I do it one more time because it's 2. Was it up 8 over 2? Yeah. 1, 2, 3, 4, 5, 6, 7, 8 over 2. And what shall I call that point?
B prime.
B prime, good job. All right, now you're going to do the same thing for C. Count your up and over from the red dot to vertex C. Do that now. Count your up and over.
Up 2, right 10.
Up 2, right 10?
Yeah.
Okay, so 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should I end up on vertex C? And I stop, or one more time? One more because the scale factor is 2. Up 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I ended up at 8, -6. Anybody else?
Yeah.
Yeah? All right. So now you're going to connect your A prime, B prime, and C prime, and it should look like a dilated image from your original, twice as big. So should it still be a right triangle?
Yeah.
Yes, it should be. right angle, right angle. Do you see that? All right, so this is the dilation of this, and they are similar triangles. What does similar triangles mean? That corresponding angles are what? Congruent. So angle B and angle B prime are congruent. Angle C and angle C prime are congruent, and A prime. All right. What should also happen is the scale factor, the side length should be proportional. Can anybody count the distance here between A and B? 6?
Yeah.
Can you guys count the distance between A and C? 8. Now, I'm going to have you count the scale factor between A prime and B prime. Not the scale factor, sorry, the length. Count the distance, the length between A prime and B prime. 12. All right, if you guys will please count it for A prime, C prime. 16. Okay, now, because of time, I'm going to have to give it to you unless anybody's already done it. But you could use Pythagorean's theorem. 6 squared plus 8 squared equals C squared. Anybody do that in their head? What's 6 squared?
36.
What's 8 squared?
64.
64. What's 36 plus 64?
110.
What is it?
110.
110. 36 plus 64. 6, 7, 8, 9. And what's the square root of 100? 10. All right. Guys. All right. I'm going to give this next one to you again because of time, but you would do 12 squared plus 16 squared equals C squared. It comes out to be 20. All right. But you know how to use Pythagorean's theorem, yes or no?
Yes.
Yes, you've been doing that for some time. All right. So what I'm going to quickly check is that side lengths are proportional. I'm going to do 12 over 6, and I'm doing the larger one first, and there is a reason. Let's just do it for now. I'm going to check. 12 over 6 should equal, I'm doing this side now, 8 over 16 or 16 over 8? If I'm going big to small.
16 over 8.
16 over 8 should equal 20 over 10 or 10 over 20? 20 over 10. And reduce each one. We did it. We turned everything in. You'll just have to cross. All right, guys, please stop. Okay, what do they all reduce to? Come on, guys. What do they all reduce to? 2 over 1. Is that the scale factor, by the way? Should that work? Yes. All right. So, any questions? All right. Another thing you should recognize is that corresponding side lengths will always be parallel. So AB is parallel to A prime, B prime. AC, please stop, is parallel to A prime, C prime. And what else is parallel? BC is parallel to B prime, C prime. Corresponding side lengths are not only proportional, we checked up here, they are proportional, they're also parallel when the images are similar, or dilated, sorry. When the images are dilations, they will come out to be parallel for corresponding sides. Questions on that one? All right, perimeter, can you guys quickly add up the side lengths? You guys have calculators out there, do it in your head. 6 plus 8 plus 10. 24. Yes or no? Find the perimeter and the area of each triangle. All right. Do you guys remember the formula for area of a triangle? Area equals 1/2 base times height. I'm doing the small one. 1/2. What's the base and what's the height? Base is 8 and height is 6. Do we use the hypotenuse for this one? No. 1/2 base times height. Base and height should always be perpendicular to each other. That's why we use these two sides. All right, so multiply those together. And what do you get?
24.
24. All right, those will not always come out to be the same, but I would like you to find it now for the bigger, the larger triangle. Perimeter, add up your sides. Area, 1/2 base times height. Do that quickly, please.
I have a question.
Mm-hmm.
So for the bigger image for A prime, B prime, C prime, when we just times 24 times 2?
For this one?
Perimeter, yeah.
Yes. All right. Did anybody actually add it? What was this? 12 plus 16 plus 20. What did you get?
48.
Now he said for the perimeter, could we just take the original and multiply it by 2? Yes. That comes up down here. So let's look. What is the ratio of the perimeter? Please stop. I always do for dilations, I do new over old. So what was the new perimeter? 48. I'm going to write it like this. Oh, no, I'll just put a fraction. Over, what's the perimeter of the smaller one? Or the original one? 24. And what is 48 over 24 reduced to? 2 over 1. A coincidence?
And the areas?
Yes, it is.
Also, what about the areas? Can you do that?
We'll have to check. So let's check. So he's saying it worked for perimeter, and I'm erasing this because I did have in the wrong spot. Thank you, Merida. And what does go here? Merida. And I've been good all this, and there's a reason why. I'll tell you later why.
Is it
No.
from that one movie? That one Disney
No, it's just I was no. All right. What is the scale factor? We already found it. It was what? I'm just going to pick one of these. I'm going to write 12 over 6, which reduced to 2 over 1. This is not a coincidence. The fact that the scale factor was 2 and the perimeter was twice as big, not a coincidence. Now, Cody asked, can we do the same thing with the area? Let's check. So let's actually do it for this bigger one. Area equals 1/2 16 times, what's the height? 12. Anybody plug it in?
192.
It comes out to 96.
96. All right. Is that twice as big? No. Let's figure it out. Let's reduce it. What is the ratio of the areas? So I'm going to put it right here. I'm going to do new over old. So 96 over what? 96 over 24. Can you divide that and see if it reduces?
4.
Does it equal 4? So can we just double it? No.
No.
So perimeter, you double because the scale factor was 2. Area, you do what? Multiply it by 4. And the reason is because the scale factor is 2 and area is squared, and what's 2 squared? 4. So what if your scale factor was 3? What's 3 squared? So then your area would have been 9 times bigger. Got it? Yes. I'm okay. Thank you. All right. Are we good? Does that make sense? Yes? All right. I'm going to have you guys, we're going to jump over to number 3A. 2 would have gone right in here, but we are running out of time, so I'm going to do 3 right now. So right now I want you plotting these 4 points, A, B, C, and D. Go. Hurry. Hmm? Be nice. Thomas. Psst. Plot. All right. Do you end up with a triangle
No.
or a rectangle?
A rectangle.
All right, so connect. If you haven't done it already, please stop. Okay, so it says here the center of dilation is negative 13.3. So it is right here. Do you guys see that? That there is going to be the center or the point of dilation. Center of dilation. All right. What's the scale factor here?
3.
How much bigger is the area going to be?
9.
3 times. The area 9 times bigger. The perimeter how much bigger? 3 times. All right, let's see if that works. All right. Do you guys want to start with A, B, C, or D?
A.
Okay. I heard A. Closer. All right. How far from this dot to A? It just goes right how far? 3. So I'm going to do that 3 times, and it's just over to the right, no rise. Do you see that? So over 1, 2, 3, that's the first. 1, 2, 3, that's the second. 1, 2, 3, it is the third. Do I end up on a dot that's already there?
Yeah.
Yep, so I'm just going to color over it and call that A prime. All right. Count the distance from my dot of the point of dilation to D. Can you guys count that length? That's your what? Your 1, 2, 3, your group 3. Make sure your name and scores at the top, and any late work goes up there. All right, I'm sorry, what was the length? 9. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9. The first time should I be on the dot? Then I do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that enough, or one more time? That was 2. Scale factor is 3, so do I need to do it again?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so this is D. All right, can you guys count your up and over from the center of dilation to B? Up and over. Go. How far up? How far over?
It's up 4, right 4.
Up 4, right 4? Let's see. 1, 2, 3, 4. 1, 2, 3. Did I count off on mine?
Yeah.
Is it up 4, right 4? Up 4, right 3? Can you guys check?
Right 3.
Up 4, right 3?
Yeah, right.
All right, so double check yours. Okay, so I'm going to do that a total of 3 times. So 1, 2, 3, 4. 1, 2, 3. There's the first. 1, 2, 3, 4. 1, 2, 3. There's the second. 1, 2, 3, 4. 1, 2, 3. There is the third. Yes or no? All right. And now do the same thing for your C. Count up and over quickly from the point to your C. Please stop. Do you have any late work to turn in? No. Okay. All right. Can anybody tell me how far up and over? Up 4 over to C. 9.
Yeah.
1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the first time, and do it again 2 more times. Please stop. All right, and this is C prime. Should I still end up with a rectangle? Yes. It should be similar, which means corresponding angles are congruent. And what do we know about corresponding sides? Be careful, they're not congruent. They are
Similar.
the polygons are similar, but corresponding side starts with the P. Proportional. Good job.
Proportional. Fabulous.
All right. Okay. So this one should have been over just a smidge bit more. Okay. Yes. All right. Can you guys do a quick count? What's the length from A to D? 6. Can you count? So that means this is going to be 6. Count this one here. What is this? 1, 2, 3, 4. And this one's also 4. Now, can you do, let's do without the count. If it's 3 times as big, what should this length here be?
18.
And the height here should be, can you guys just do a quick count and check?
Yeah.
Did it work?
Yeah.
All right. Shh, stop the talking. So let's see if the conjecture that we made earlier about the perimeter getting 3 times bigger, and you said the area would get 9 times bigger. Let's check. Okay, what is the perimeter of this one here? 6 plus 6 plus, oh, I would do this. 6 and 4 and 6 and 4 is what? 20. Can you guys find the, I'm going to do the perimeter really quick. For the big one, 18, 18, 12, and 12. What's that perimeter? I heard somebody say it. 60. If you do 18 plus 12 plus 12, it should come out to be 60. I'm going to cover this. What's 20 times 3? Did it come out to be 3 times bigger? Cody's the one who pointed that out earlier. Yes or no? All right. Now let's check the area. Formula for the area is not 1/2 base times height. What's the area? Length times width. So 6 times 4 is 24. Can you guys do 24 times 9 and see what you get? Because that was our guess. 216. All right, let's check if that's true. Over here, you're doing 18 times 12. Can you plug that in your calculators? Ooh, did it work? Okay, so who can tell me why the perimeter got 3 times bigger? Because the scale factor is 3. Why did the area get 9 times bigger?
Because you have to square it.
Square, because area is squared. You take your scale factor and squared. 3 squared is 9. That's why this one was 4 times bigger, because 2 squared is 4. Does that make sense?
Yeah.
All right, we're going to quickly fill in. What is the scale factor? 18 over 6 or 12 over 4, or it's given to you. What is it? 3. What is the ratio of the perimeter? 3. 3 to 1. What's the ratio of the area? 9 to 1. Or you can write it like this if you choose. It's up to you. Now, how did we find these? This was 60 over 20, and this was 216 over 24. All right, before I give you the worksheet, there is one thing I want to write down here quickly. Are you ready? Yes? Scale factor. Write this down. Scale factor will always be new image over old image. The scale factor will always be the new image over the old image. For dilations only. For dilations only, your scale factor will always be the new side over your original side. Please stop. All right? So it's not always left over right or here over here. It's always new image over original image. Is this clear? All right.